So what is TypeScript? TypeScript is a superset of JavaScript, meaning it can do everything that JavaScript can do, but it adds more features to it, making it more powerful. And it should be noted that JavaScript is what the browser runs. TypeScript isn't run in the browser, so you will need a TypeScript compiler, and there's a very powerful customizable compiler that TypeScript offers, and that can compile the TypeScript code into JavaScript, and it can change all of our new features such as static types and all of that sort of stuff. And rather than us writing really complicated JavaScript, it's much more human manageable to type this sort of TypeScript code and then get it compiled down. And that leads us to one of the best features about TypeScript, and that is static types opposed to JavaScript's dynamic type, meaning that you can detect errors before runtime and you can fix them in development. So yeah, you can compile the next generation JavaScript so it can work in older browsers, similar to Babel, except the TypeScript compiler can do it all for us. And in addition to the static types and type safety that TypeScript gives us, there's also some other features such as using interfaces and generics, namespaces and modules. So let's go ahead and we'll go ahead and install TypeScript. And just to note that TypeScript does require Node.js, so go ahead and download the stable version or the latest versions, up to you. So we'll go ahead and we'll install that in our project. So we can just do an npm install, and we can install TypeScript globally with the G flag. So let's go ahead and do that. And what we'll do is we'll make a HTML file. So we're in Visual Studio Code here, so I'll call this index.html, and I highly recommend Visual Studio Code as a text editor. I have a video on how to set up and all the latest extensions that you need. But we can use Emmet, we can just use an exclamation mark here, enter, and that gives us our HTML boilerplate that we need. And right under the title in the head, we can attach a script. Actually, let's just make the script first to see how the compiler works. So we'll go ahead and we'll say new file, and I'll just call this index.ts. And now that we have the TypeScript compiler, we can compile our code into JavaScript. So just to see an example of this, let's just do okay, so let's just do let my string equal John. So in TypeScript we can see that this infers the string type, and that's relating to inference. So it's in the standard situations for the basic types like strings and booleans and all that sort of stuff. It's often better just to leave it to the inference, but in TypeScript we can explicitly give it a type. And notice I'm using a lowercase for all these types that we're using, because the uppercase refers to more of like the object notation constructor. And with reference to the TypeScript documentation, it says don't ever use the uppercase equivalent types. These types refer to non-primitive boxed objects that are almost never used appropriately in JavaScript code. So while we're getting started, we definitely won't be using any uppercase strings. And it says do use the lowercase ones. And instead of the object use the non-primitive object type. So we'll get into that a bit later. Just wanted to point that out. So yeah, so we can explicitly call this variable a string, and if we do that, we won't be able to reassign this variable. So let's say my string, and this can't be equal to a number, and the TypeScript compiler and TypeScript just points this out for us immediately, and that's what it sort of does for us. Now it should be noted that we'll get some errors if we do try and compile this, but it will still compile the code. It's just up to the user to take the errors on board and create code that isn't, error prone. But yeah, so I will just console log this so we can see how the compiler works. So I'll just save that, and now to use the compiler, all we do is we just type in tsc and whatever the name of the file is. So I got index.ts, and we'll notice that it just spits out the JavaScript code for us. So notice that it spits out ES5 by default, and that's because that can be used in all browsers. And this duplication error is just because we have this variable defined in a different file, but if we just close this file, that gets rid of that. So yeah, TypeScript's just looking out for duplication. But yeah, we'll notice that it's the ES5 with the variable rather than the let or const, and it's pretty much exactly what you would think it would be. It just removes this string. This is all these types, and it's just checking before the code is compiled so we can spot the errors in development. For example, if we reassign string, my string to equal 5, and then we try and compile this. Now it does spit out this error here, my string equal 5, found one error, and it warns us here as well. But if we ignore that, it will technically still compile the code. So that's just something to be aware of. And what we'll do is we'll attach the index script. So we want to attach the JavaScript file, and we can do that. We can just go script/source, and we can get that index.js, make sure it's the JS, and we're not editing the JS, and then we can use this defer sort of flag here. So what this will do is defer in the script. What it's doing is it's a Boolean attribute, and it specifies that the script is executed when the page has finished parsing. So it's sort of equivalent to having it at the bottom, but this is sort of like the new standard, I suppose. So let's just attach that, and I've got this live server extension, and that will allow us to right click, and we can go to open with live server. And what this is doing is it's giving us like hot reloading. So if we make changes to the JavaScript file, and this is just like a Google Chrome error. We'll just try to ignore these at the moment. But yeah, it says live reload enabled, and then we just get our 5, which what we console logged. Okay, so before we get into TypeScript and the types, I wanted to just talk about the compiler a little bit. And instead of, every time we make a change, let's say we change this to John with a capital H, instead of saving this and compiling this and waiting for it to compile, then that updating in the browser. I'm not sure actually what happened there. Must have pressed the wrong button or something like that. But yeah, if I change this string to Larry, let's say, and I save this index, and then I use the TypeScript compiler, so that will generate this new string, and that's getting console logged, and then that hot reloads to Larry. That's what was supposed to happen. So okay, so rather than doing that compile process each time, what we can do is we can add a watch flag. So for example, we can go tsc, the TypeScript compiler, on the index file in TypeScript, and then add this either dash wash, like double dash and watch, or just one single dash and W. And this will sort of create this watch mode, so it's constantly looking for changes in that file. So if I change this to Larry2, I save that, you get Larry2. If I change it to Larry3, you know, you get the idea, you get the hot reloading, you don't have to compile each time. So that's good, like while you're sort of developing. So okay, that's all well and good, but what if we had multiple files? How would we go about watching multiple files? So I just do a Control-C, and if I add a new file, and I'll just call this like random.js, and sorry, that's a TypeScript file, random.ts, and let's just say I do a console log clg with the extensions. That's the ES6 JavaScript snippets, ES6 JavaScript snippets extension, but I'll just say random log, and I'll save that. Oh, sorry, clg space enter, random log, save that. And what we want to do is we want to we can do something like this. So tsc dash init, and what this is going to do is it's going to create this tsconfig file, and most of these settings are commented out and we don't really need most of them. Just a quick overview. So if we were making, say, a node application and we wanted to have the target type or the JavaScript type in ES6 syntax with the lets and the const and the arrow notation and all that, we could change this to ES6. So that means when we run that compile code, and I'll just compile it once here, that when we take a look at our index dash JS, is that right? Let okay, so now that we've created this tsconfig file, rather than doing the specific file, we can just run tsc, so just the TypeScript compiler, and notice that that compiled both our random JavaScript and the index JS file. So if we take a look at that, and we can see that now that it's using this use strict and let with this ES6 syntax, and you can go ahead and you can see the different styles of JavaScript you need, and you can just do a control space to see the IntelliSense, but I'm going to revert back to ES5 here. So that's that. So yeah, TSC, is the TypeScript file for all the TypeScript files in that directory, and likewise we can do a TypeScript compile with the watch flag on it, so they'll constantly be running. And then if we open up this random log, add an exclamation mark, save it, and that should be oh well, we need to attach the file as well in index.html, so let's go ahead and do that, and I'll just call this random. And now we see this random log with the exclamation mark as well. Just one thing, I'll just do okay, so one thing to note is we can also exclude files if we want to. So let's say we wanted to exclude this random JS file from, or this random TS file from being compiled. We can scroll down to the bottom here and write, let's see, so these are the compiler options. So right here below the compiler options we can do this exclude, and it should be noted that exclude, if exclude isn't there by default, it'll exclude the node modules, because often TypeScript projects are associated with npm or node modules. You might have a framework or something like that. So this is equivalent to excluding the node modules, but you have to write that node modules exclude that. Even though we don't have node modules in this case, if we did, we would have to write exclude node modules if we were to exclude something else. So if I wanted to exclude my index, let's exclude random .typescript. Now we have to exclude node modules as well, because they'll no longer be the default, and they'll look for all the node modules files and all the TypeScript files in it, because that's in our directory. We don't necessarily want to be doing something like that. So now, if I make a change, so let's just revert this exclamation mark, and I save that. Notice the compiler didn't compile, and even if I refresh it, this exclamation mark is still there because it's still the last compiled version of it. What we can do as well, but we won't necessarily need to do that in this case, but we can have an include sort of array of files to include as well, and this will sort of so let's say I had a couple more TypeScript files. Let's just make a new file, file1.typescript. Okay, so that's going to do that by default. Let's just turn off this for now and delete the JavaScript file. Just like the bin. So if I want to include, let's say, file1.ts, so what that would do is it will only actually, this might be better if I do include index.js, and then I save that, and if I go ahead and I do a TSC, so we've got an error in here. TSC. Oh, sorry, that's because it's a TypeScript file. So I save that, do a TSC. Notice that didn't create another F1 JavaScript file, and it also would have only compiled the index TypeScript file. So what this is doing is this is including this is all the files to include in to compile. So everything that's not in this essentially won't be compiled, but if we do it after an exclude, that means it also won't be included in the TypeScript file. For example, if we had a folder, and it had some, different files in it, different TypeScript files in it, but we wanted to, and it had another subfolder in it, and we wanted to exclude all those subfolders. But keep the files not in that nested folder, then what we could do is we could include, so I might actually just do this as an example. So I'll make a folder and I'll call it random folder, and then in this random folder I'm going to create another folder, rf2, and then I'll create another folder, rf3, and then I'll make a file in this random folder too, rf2.typescript, and I'll make one in here, random file3.typescript. So I'll just put a random log in it just so it has something in it. So I'll save that, save that, save that, close the files. So let's say we only wanted to have this random file 2 compiled and we didn't want the random file 3 compiled. In our include, so in our exclude, we could have something like this. So let's say we want to exclude the folder random folder / random folder 3. We don't want random folder 3, but we do want everything in random folder 2. So if we include random folder, we include that, and then we do a TypeScript compile. Notice that it's compiled the random folder 2 TypeScript, but it hasn't compiled the random file 3 TypeScript because it includes everything in here except for the things that have been excluded. So I'm going to go ahead and just delete this include and this random folder and strip it back our project back to not having this random folder. So I'll delete this into recycle bin. Okay, so also going to delete this F1 file, and okay, so that's pretty much an introduction to the TypeScript language, the installation and the configuration settings of the compiler and why we would want to use it. So in the next video we'll start some TypeScript and go into some of the basic types. So I'll see you there.